Hi everyone, my name is Daniel and I'm a JavaScript developer. Today I'm going to show you how to containerize your Node applications using Docker. So let's see what we're going to go through today. First, we're going to deploy our application in the traditional manner without containers. Then we're going to look at what issues this could have when working in a real-life project. Then I will introduce you to containers and Docker. And we're going to change our deployment approach to using Docker and see how that solves the issues that we highlighted before. So let's look at what application we'll be deploying. It is a simple application just to demonstrate that we can link the database with the backend with the front end. So it consists of three components. For the database, we're using Elasticsearch. For the backend, we're using a simple Express server. And for the front end, it's just vanilla HTML, CSS, and JavaScript. And we're building it with Webpack. The application provides three functions. It creates JSON objects and stores it into the database. It reads all the JSON objects from the database. And it also has an endpoint to delete all the JSON objects in the database. So how can we run this application? Because it's based on Node, we have to install Node. Because it uses Elasticsearch, we have to install Elasticsearch. So this involves installing the Java development toolkit, downloading the Elasticsearch Debian package, and then running it as a daemon service. Then we have to clone our repository, install the Node dependencies, build an application, and then we can run our application. So let's do all that now. We've already installed Node and Elasticsearch just to save time, and we have already cloned our repository into the front end and the back end directory. So now let's do npm install on each one. And also to make sure that the database is running. So if we do sudo systemctl status Elasticsearch, at the moment it's loaded but it's inactive. So we can do the same instead of status, we do start. And this will start our Elasticsearch service. We can check the progress of its initialization by sending a GET request to the Elasticsearch port. And if responsive to this JSON object, it means Elasticsearch is running and available to service new requests. So Elasticsearch is running, so let's run our backend. We can do that by using npm run start. For our front end, it's a bit more complicated. We have to build it with Webpack first. So let's do npm run build and npm run serve. So now our backend is serving at port 3000, and we can check this by sending a curl request to the backend. This is sending a GET request, and our backend will reply with a list of documents stored inside a database in response to a GET request. So right now we have no items in the database, so it should come back with an empty array. And it doesn't because I forgot to delete it from the last run. So let's delete it, and well, basically we know it's running. And now to verify that it is working, we can send a post request to the backend, and it's returning with an ID to say that we have added it to the database with this ID. And if we curl it, we get the object back. If we delete it, is deleted from the database. Right, so the backend is talking to the front end, to the database. So now we need to check if the front end is interacting with the backend. So I created this very simple front end application. All it does is generates a JSON object, submits it to the backend, and the backend writes it to the database. And I can generate multiple objects. And if I curl it on the backend API, the same objects appear: green5, bonobo, bonobo, anteater, flamingo, dog, right? And if I clear it on the front end, we cannot query it again in the backend. So we know the front end is talking to the backend, and the backend is storing things into the database. Before we continue, now that we're happy that it works, let's stop our application and reset everything. Perfect. So what was wrong with this approach to deployment? First, there's a lack of consistency. When you're working with a team, everyone has different environments, different operating system. What works on your machine doesn't necessarily work on someone else's machine. And this might lead to breaking production because a developer may say, but the test runs perfectly on my machine, it works on my machine, it should work in production as well. There's a lack of independence in the sense that libraries like Elasticsearch are installed globally. So if I have two applications I'm developing in my local machine, they have to use the same version of Elasticsearch. Otherwise, I have to install and reinstall Elasticsearch every time I want to switch projects. It's time consuming. I've downloaded Node, I've downloaded Elasticsearch to save time in this presentation, but to set them up every time would take about 15 to 30 minutes. And we have to do this for every single environment. So if we have a QA environment, development environment, staging environment, for every environment you have to repeat the exact same steps. If you want to upgrade any of the software, for example, you want to upgrade Node from version 6 to version 8, then you have to go into each server to do that. So this time-consuming aspect scales with the number of environments you have. It's error-prone because humans are humans. I may have forgotten to pass in an environment variable. Just now I forgot to clean up the database before I started this video. So humans are prone to error. Downtime. Currently we're deploying a single component of our application on a single machine. So there's a lot of single point of failure. If my computer breaks down now, the application is down. If my backend fails, my application is down. If my database fails, my application is down. This is not good for enterprise level applications. Last but not least, there's a lack of version control. With applications, we can roll back to the last known good version if the current application code is broken. Why can we not do that for deployment? If we deploy a bad version of the application, why can't we just roll back? Here's where containers comes in. I'm going to tell you what containers are, and then we're going to use it to deploy application, and then we're going to go back and see how that solves the issue we just raised. So first, containers is a method of virtualization. What that means is that it allows you to run applications in an isolated environment. You can install all the dependencies within the virtual environment, so it's portable. So there's two types of virtualization that you probably heard of. Virtual machines, which uses a hypervisor to emulate the hardware. So the application running inside a virtual machine will think it is running inside a different physical machine, and it can interact with the hardware like you can do with any physical machine. And then you have Linux containers, which uses Linux kernel features like cgroup and namespaces to isolate the environment. It does this by grouping processes inside a container inside its own group, and then packaging resources like process IDs, storage, network, CPU, RAM, packages these resources and assign it to that group. So any processes that runs inside a container runs on the operating system's kernel, and you don't have to emulate the hardware or use a hypervisor. So Linux containers is more like a lighter version of virtualization. So when you think about containers, you think about Docker, but they're not the same thing. Docker is not a new container format. Linux containers have been around for just over a decade. So in terms of operating systems features, it's relatively new. So Docker doesn't try to reinvent the wheel. Instead, it provides a standard way of defining containers using Docker files, which we'll look at in a minute. It also provides a standard way of running the containers using the Docker engine. And it provides a place for people to share the images that they build from Docker files. And that place is called Docker Hub. It's like the npm registry for node packages. You have the Docker Hub for Docker images. So let's look at how to work with Docker. First, you will write a Docker file which basically maps the manual steps that you take with instructions inside the Docker file. So before we install Node, now we just do from Node. That will pull in a Docker image from Docker Hub, which has set up the environment so that you can run Node on the image directly. Then we run npm install, npm run build as we did manually, but now it's specified as code inside a Docker file. Then we run docker build. Docker build takes each layer, each instruction, and run the command, and any file changes, whether addition or deletion, those file system changes are recorded in a read-only layer. So Docker will run each instruction line by line, and it will build up the image layer by layer. At the end, you will have an image which has all the dependencies you require to run the application. And to run the application, you similarly run docker run. What happens here is that a new writable layer is added on top of the image layers. And any file changes that you want to make to the application is contained within the container layer. This means you can have one image and run 100 containers on top of it. And all that does is you have 100 container layers coming off the image layer. So let's migrate our existing application from manual deployment to using Docker. So before, we had to set up Java and install the Debian package and manage the services ourselves. With Docker, all this setup is already done for us by the Elastic team, and they publish a Docker Elasticsearch image on their registry. So all we need to do is pull it from the registry and run it. So we pulled it in, and now we're running Didn't prepare very well for this. Just give me a moment here. I forgot to clean up again. So, right. So we pulled it in and now we're running it. And as you can see, it's coming back to say this container has been created. So now if we do curl localhost 9200, we get a response back. But this time it's not from the Elasticsearch instance running on our local machine, because if we check, the local instance is not running. The instance is running the instance that is running is on the Docker container. So let's similarly deploy our backend. So in this branch, I already have a Docker file here, and I just need to run build to build an image based on this Docker file. After the image is built, I need to run it, and it's run already with this ID. So now if we curl 3000, port 3000, we get an empty array as we did before. Same thing with the front end. We're building the Docker image based on the Docker file, and we're running it, and it's run. So now let's check everything is working. Generate a JSON object, submits to the database, is added to the database. We can query it from the back end, and we can delete it, and it's deleted in the front end. So basically everything that we tried before works when we deploy it using a container, using Docker. And I'll just show you quickly. You can run Docker PSA to see other Docker containers that's running on your machine, and you can see roughly front end, back end, and Elasticsearch. They're all up and running. So to stop our application, all we need to do is Docker stop front end, back end, and Elasticsearch. Right, let's go back to the presentation after this is done. Right. So now if we do curl 3000, it doesn't work. If we try to into curl 9200, it doesn't work. And our front end server is not serving. So that completes our cleanup. So what problems does Docker solve? It provides consistency because everything that it needs to run is packaged inside the container. It's self-contained, and it means it's portable, right? The dependencies are included, so I can give it to anyone on any machine that has Docker installed and they can run it. Provides independence. Again, because other dependencies are inside a container, you can have one container running node 8, another container running a legacy node 6. It saves time because before we have to run many commands, and now it's just a few commands. Docker pull or Docker build, and then Docker run. It reduces errors. It reduces human errors for me forgetting to pass in an environment variable or forgetting to use a flag in a command. Everything is specified as code. It's a step towards zero downtime. Right now, we're still deploying only a single instance of every component in our application. So there's still a single point of failure. But eventually we can move towards using cluster orchestration tools like Kubernetes. And all these cluster orchestration tools uses containers. So although using containers doesn't necessarily prevent downtime, it helps us to migrate to using these tools, which does prevent downtime. And last but not least, we can version control our Docker file. So if there is a new dependency or we need to do an extra step in setting up the application or the service, we can just make a change to the Docker file and the process of running the application will still be the same. Docker build, Docker run. And if there is a bad deployment, then we can simply roll back to using the last known good version of the Docker file. So this is an introduction to Dockerizing applications, JavaScript applications. Obviously we couldn't cover everything and we did not use any of the best practices. So the next steps for you to go back home to do is to look at using best practices and how to optimize your Docker images. Some of the things you should look at is using multi-stage builds and creating microcontainers with Smith. Smith is a tool by Oracle which analyzes your containers and identify all the programs that is not needed to run your application, and it removes them. So keeping your image size small is super important because let's say your production is on fire and you have to roll back to the previous Docker file. If your Docker image is 1 gigabyte big, you have to transfer that 1 gigabyte to the production environment, which is burning, and for you to redeploy your application using that image. When your production is on fire, every second matters, so having 1 gigabyte image does not help. And as I've mentioned before, using cluster orchestration tools like Kubernetes or Docker Swarm allows you to have high availability and performance for your application, but that's a completely different beast on its own. So thank you for watching and listening, and I hope to see you next time.